All right, so today we're going to be looking at parallel lines and transversals. Parallel lines are any two lines that are consistently the same distance from each other. So say we have these two parallel lines. And in math, to identify or to signal parallel lines, you'll see some little arrows midway in between, somewhere like this. Not at the end of the line segment, but somewhere in the middle. And that just tells you that these are going parallel. And a transversal is a line that will cross through the two parallels. And there are some characteristics that we're going to go over with transversals. And what happens when it crosses a pair of parallel lines. So a transversal is going to create four angles. Technically, you got two intersections. And at these two intersections, you create four angles. 1, 2, 3, 4, and then another 4. 1, 2, 3, 4. So a total of 8 angles. And there are characteristics that you notice. So just by looking at this, it kind of looks like this obtuse angle is the same as this obtuse angle. And it actually is. Those are called corresponding angles. This angle corresponds to this one. And how can I tell? Well, of the two intersections, this one's on the upper left corner. This angle is also in the upper left corner, so they're corresponding. And I have another one in the upper right corner, and this one's also in the upper right corner. So those are corresponding. And this angle on the lower left of this intersection will correspond to this angle in the lower left of the intersection. Now notice I'm putting little markings. Each marking shows that they're corresponding and they're congruent, meaning same size. So anytime you have a geometry figure that has markings like this, it's made so that you can identify what is considered to be congruent. So I'm showing you by doing this, 1, 2, 3, 4, 1, 2, 3, 4, that those angles are congruent. So 1 marking, 2 markings, 3 markings, 4 markings. So you can also do different colors, it doesn't matter. But I'm just showing you that the position that they're in helps me to identify the corresponding parts, which therefore means that they are going to be congruent. So last one, I just want to discuss. This one is in the lower right corner. This angle is in the lower right corner. They will be the exact same size. We call those congruent. And the vocabulary word for those is we call those corresponding angles. And remember, corresponding just means like matching. So let's write that down. Corresponding angles are congruent. So you have corresponding angles are congruent. Corresponding meaning in the same position. So you look at the position of one angle on one intersection, has to be in the exact same position on the other intersection, and then we can call them corresponding. All right, so let's look at one example on how we use these corresponding angles. Say I have these two vertical parallel lines, and they're being cut by this transversal, and I'm told that this is 110 degrees, and this is angle 2, and this is angle 1. Now, not to be confused with 2 and 1 with degrees. If it doesn't have the little degree symbol, it's just telling you the label of the angle. The only time it represents a measurement is definitely when you see the degree on there. All right, so for the first one, find the measurement of angle 1. That's a little angle symbol. And the second question is to find the measurement of angle 2. All right, so we're going to use what I just told you. So again, even though these are vertical, the same characteristics apply. So we have two intersections, and we want to identify the location and see what matches or what's corresponding. So I say angle 1 is here. It's in the lower left corner. Of this intersection, 110 is in the lower left corner. So I know that these are corresponding angles. So 110 degrees and angle 1 are corresponding. And because I know they're corresponding, that means that they are congruent. So I can also write down that 110 degrees is congruent to angle 1. So therefore, because we know congruency means same size, angle 1 equals 110 degrees. All right, and let's look at the next one. Measurement of angle 2. Angle 2 is on the upper left-hand corner. This one's on the supplementary to angle 1. So I know that angle 2 and angle 1 together should be 180 because this is actually going to be 180 degrees. So that's 180 degrees together. So I know that angle 1 is now 110 plus angle 2 should equal 180. And with that, we're going to solve this for angle 2. So we're going to subtract 110. And we're left with angle 2 equals 70 degrees. All right, so that's how you use corresponding angles, making sure that the location of each angle at the intersection, if they're corresponding, then you know definitely they're the same size. They're congruent. All right, so let's look at another example. Example 2. And that's also another pair of vertical parallel lines. And we got angle 1, angle 2, angle 3, angle 4, 5, 6, and 7. And this angle is 75 degrees. And we're trying to find all of the angle measures. All right, so we're going to start with angle 1. Angle 1 is vertical from the other side. We've discussed vertical angles before. Vertical angle is any angle opposite from two straight intersecting lines. So I have two straight intersecting lines. 75 and angle 1 are opposite of each other, so I know they are congruent. So angle 1 is 75 degrees, and I'm going to just write on here vertical angles. That's my reasoning. And angle 2 is going to be supplementary because they're both on this straight line. So I know that if I swing all the way from here to here, that's going to be 180. So if I already got 75, I just have to figure out how much is left. So I'm going to say the angle 2 is equal to 180 minus 75. And that's going to be 105 degrees. I'll write it here. And the reason for that was it's supplementary. So I'm going to just be writing down what we used, what relationship we used to find the missing angle. And the next one will be angle 3. Angle 3 is also either vertical to angle 2, which is exactly the same because again, you're making this X shape and 2 and 3 are opposite of each other, so they're congruent. Or you can also say that 3 and 75 together make 180. I'm going to use vertical angles there. So we're going to just say that it's also 105 because angle, oops, do that in red. Angle 2 and angle 3 are vertical. Oops, vertical angles. And number 4, angle 4 is corresponding to angle 1, right? Corresponding angles, meaning they're in the same position. 1 is in the lower left corner, 4 is in the lower left corner. So I know for sure these are going to be the exact same size. Do I know angle 1? Yes, I do. 75 degrees. So this one's going to be 75 degrees. Angle 5. Angle 5 is corresponding to angle 2. 5 is in the upper left corner of this intersection. 2 is in the upper left corner of this intersection. They are corresponding angles, so they are also congruent to each other. So this one's 105. Angle 6 is corresponding to 75. Upper right corner, upper right corner. Corresponding angles. And angle 7 corresponds to angle 3, which we knew was 105. So all of these, we are using corresponding angles. So if you know your properties, you should be able to figure out all of the angles by either vertical angle relationships, if they're opposite of each other. If they are in the same position, you can use corresponding angles. And if one of them makes up the rest of the 180 on a straight angle, that's another one. All right, I can put supplementary here, or I can even put a straight angle. All right, so example 3. And this is really just memorizing what angle relationships we have. So let's say we have parallel lines that are diagonal, and I have this is 60 degrees, and I have angle 1. I want to know how big is angle 1. Find the measurement of angle 1. So, what ideas do we have here? What properties can we use? What angle relationships is going to help us figure this out? Now, there is more than one answer, many ways to think of the same thing. So I can say that this one was also going to match 1, right? This angle's in the upper left corner. That one's missing, completely blank. I don't know what it is, but I do know that it also is the same as angle 1. I could also say that this one here is going to be 60. Because 60 is in the lower upper right corner. This missing angle here is in the upper right corner. So I can label this one 60. Right? So if this one's 60, because I know it corresponds to this one, I can also figure out what all of this is, because here I have 180 degrees. So I'm going to put this in red. I know that all of this is 180 degrees. So I'm going to use my concept of supplementary angles and try to find angle 1. So angle 1 plus 60 degrees, I know that together those two are going to equal 180. And if I subtract 60 from both sides, I get angle 1 is equal to 120 degrees. All right, and that was me using supplementary angles and corresponding angles, right? I had to tell you that these were corresponding, and then once I knew this one corresponded to that one, I was able to use this angle and create my supplementary relationship there. All right, so let's look at the next one, or the last one. All right, so before I get into example 4, I want to describe some other angle relationships that we're going to be seeing that are really important. So let's say we have, again, two parallel lines. And you probably were noticing some angle relationships that came out to be the same values. So really quick on the other example. Notice how we got 75 here, 75 here, we got a 105 there, a 105 there, and a 105 there. So you see some patterns, you see some repeated numbers. So, and in doing this, we noticed 5 was 105, angle 7 was 105, angle 2 was 105, angle 3 was 105. So there are other relationships going on. So we're going to actually give you the names of those relationships so that way later when you see them in a figure, you'll be able to identify them in a diagram. All right, so if I have an angle here and here, those are considered exterior because they're on the outside of the parallel lines. If I have an angle here and here, those are considered interior because those two angles are on the inside of the parallel lines. Now, those are not the only two exterior ones, right? We also have these on the outside. So you have two pairs of congruent angles that are on the exterior of the parallel lines. Then you have one pair of congruent angles inside, and you have this other pair of congruent angles on the inside. And there is a name for these, and the exterior angles are called alternate, exterior, I'll just put angle sign, alternate exterior angles, and these are considered alternate also, interior angles. Now, the word alternate, for me, I think of it like alternating back and forth, back and forth. So it kind of looks like it is back and forth, right? Right side, left side, right side. And then right side, right side. So it kind of makes sense, right? Alternating exterior. So on the outside, one's on the right, one's on the left. Also on the outside, one's on the left, one's on the right. So the name isn't really as important as much as identifying them in the diagram. So let's look at the last example now. I had to give you a little information before I gave you the next example. All right, so I drew them not in the same orientation as the other ones, but we should be able to identify this time. And what we're going to do is we're going to just name the relationship between the two angles, okay? So, describe the angle relationship. First one would be between 3 and angle 6. So if I tell you, let's look at angle 3 and angle 6. What's the relationship between those two angles? Well, they're on the outside of the parallel lines, right? We've got the parallel lines in the middle. 3 and 6 are both on the outside of that parallel line pair, and one's on the bottom, one's on the top. You could think of it as one's on the left, one's on the right. So they're alternating, right? Left, right, top, bottom. So I'm going to say that these are alternating or alternate exterior angles. And the giveaway was they were on the outside of the parallel lines and they were on alternate sides. Right, left, top, bottom. Next one. The next relationship we're going to describe is going to be angle 2 and angle 7. So angle 2 is on the inside. Angle 7 is on the inside. 2 is on the top, 7 is on the bottom of that line. 2 is on the left in the inside, 7 is on the right on the inside. So they're alternating. So I'm going to say they're alternate interior angles. And more importantly than anything is being able to identify what angles are congruent. And they are going to be congruent. So this angle and this angle are congruent. They're exactly the same size. This angle and this angle are congruent. They're exactly the same size. Now there are more pairs that are going to be congruent that we did not mention. And there's not just 3 and 6 as the only pair of alternate exterior angles. What other pair is alternate exterior? It's going to be 1 and 8. 1 and 8 is an example of alternate exterior angles because they're on the outside exterior and one's on top, one's on the bottom, so they're alternating. And lastly, we have another pair of alternate interior. 4 and 5 are in the inside of the parallel lines. One's on the top, one's on the bottom, one's on the right, one's on the left. So those are also alternate interior. All right, so more than anything, you should be able to identify which angles are congruent. And congruent, remember, means same size. So therefore, we can find and label all missing angles when we're asked to. And there you go.